we're asked to rewrite the following two fractions as fractions with a least common denominator. Least common denominator. So a least common denominator for two fractions is really just going to be the least common multiple of both of these denominators over here. And the value of doing that is then if you can make these a common denominator, then you can add the two fractions. And we'll see that in other videos. But first of all, let's just find the least common multiple. So the least common, let me write it out because sometimes LCD could mean other things. So least common denominator of these two things is going to be the same thing as the least common multiple of the two denominators over here. The least common multiple of 8 and 6. And a couple of ways to think about least common multiple. You literally could just take the multiples of 8 and 6 and see what their smallest common multiple is. So let's do it that way first. So multiples of 6 are 6, 12, 18, 24, 30. And I could keep going if we don't find any common multiples in this out of this group here with any of the multiples in 8. And the multiples of 8 are 8, 16, 24. And it looks like we're done. And we could keep going, obviously, 32, so on and so forth. But I found a common multiple, and this is their smallest common multiple. They have other common multiples, 48 and 72, and we can keep adding more and more multiples. But this is their smallest common multiple, their least common multiple. So it is 24. Another way that you could have found that least common multiple is you could have taken the prime factorization of 6. You say, hey, that's 2 and 3. So anything that is the least common multiple has to have at least 1, 2, and 1, 3 in its prime factorization in order for it to be divisible by 6. And you could have said, what's the prime factorization of 8? It is 2 times 4, and 4 is 2 times 2. So in order to be divisible by 8, you have to have at least 3 2's in the prime factorization. So to be divisible by 6, you have to have a 2 times a 3. And then to be divisible by 8, you have to have at least 3 2's. We only have, or you have to have 2 times itself 3 times, I should say. Well, we have 1 2. Now let's throw in a couple more. So then you'll have another 2, and then another 2. So this part right over here makes it divisible by 8. And this part right over here makes it divisible by 6. If I take 2 times 2 times 2 times 3, that does give me 24. That gives me 24. So our least common multiple of 8 and 6, which is also the least common denominator of these two fractions, is going to be 24. So what we want to do is rewrite each of these fractions with 24 as the denominator. So I'll start with 2 over 8. And I want to write that as something over 24. I want to write that as something over 24. Well, to get the denominator to be 24, we have to multiply it by 3. 8 times 3 is 24. And so if we don't want to change the value of the fraction, we have to multiply the numerator and the denominator by the same thing. So let's multiply the numerator by 3 as well. 2 times 3 is 6. So 2 eighths is the exact same thing as 6 24ths. To see that a little bit clearer, you say, look, if I have 2 eighths, and if I multiply this times 3 over 3, that gives me 6 over 24. And this are the same fraction because 3 over 3 is really just 1. It's 1 whole. So 2 eighths is 6 24ths. And let's do the same thing with 5 sixths. 5 sixths. So 5 over 6 is equal to something over 24. Let me do that in a different color. I'll do it in blue. Something over 24. To get the denominator from 6 to 24, we have to multiply it by 4. So if we don't want to change the value of 5 6, we have to multiply the numerator and the denominator by the same thing. So let's multiply the numerator times 4. 5 times 4 is 20. 5 6 is the same thing as 20 24ths. So we're done. We've written 2 eighths as 6 24ths, and we've written 5 6 as 20 24ths. If we wanted to add them now, we could literally just add 6 24ths to 20 24ths. And I'll leave you there because they didn't ask us to actually do that.
Rewrite each fraction with a denominator of 10. So we have two fractions, 3 fifths and 7 halves, and we want to take their denominators of 5 and 2 and change them to be a common denominator of 10. So let's start with 3/5, and we can look at this visually. Here we can use this rectangle to represent a hole, one hole. And to show 3/5 of that whole, we're going to need to divide it into fifths, or 5 equal pieces. So let's do that. We'll try to make these as equal as possible. And so we have 3 pieces, and then finally, there we go. So these should represent 5 equal pieces, or fifths. And to show 3/5, we need to shade 3 of those 5 pieces. So 1, 2, 3 of those 5 pieces should be shaded in to show 3/5. But we've decided we don't want fifths anymore. Now we want tenths. We want a new denominator of 10. So to change this fraction over here, to change this to be tenths, we need to split each of these fifths in half. We need to double the amount of pieces. So we can do that here. And now, instead of fifths, or 5 equal-sized pieces, we have tenths. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we found a way to have tenths without changing the amount that's represented. The same amount is still shaded, but now we have tenths. So our denominator doubled. We multiplied it by 2. We have twice as many pieces. But look at what happened to our numerator. Instead of 3 pieces, now we have 1, 2, 3, 4, 5, 6 pieces. It also doubled. It also was multiplied by 2. Because if we double all of the pieces, well, then the shaded ones will also double. Each of those pieces also split in 2. So now there's twice as many shaded pieces. So 3/5 can be rewritten as 6/10. 3/5 is equal to 6/10. And again, we didn't change the fraction. We didn't change how much was shaded. 3/5 and 6/10 represented the same amount. We just changed the denominator and wrote it a different way. So 3/5 can be rewritten in tenths as 6/10. And now for 7/2, we want a denominator of 10. So we could draw it out, or we could try to use this pattern we just noticed up here to figure out how to make halves turn into tenths. To get from fifths to tenths, we had to double or multiply by 2. To get from halves to tenths, we'd have to multiply each of our pieces times 5. Times 5. Each of our halves would be split into 5 pieces. So we'd multiply 2 times 5 to get tenths. And, like the pattern showed us up here, if the denominator is multiplied by a number, we multiply the numerator by the same number, because those shaded pieces would also be split 5 times. So we'd multiply our 7 times 5 also. These should match. The numerator and denominator are multiplied by the same number, and 7 times 5 is 35. So 35/10 is equal to 7/2. So to change these two fractions to have a common denominator of 10, 3/5 will become 6/10, and 7/2 will become 35/10. You have two fractions, 1/4 and 5/6, and you want to rewrite them so they have the same denominator and have whole number numerators. What numbers could you use for the denominator? So here's our fractions, 1/4 and 5/6, and we want to rewrite these fractions to have new denominators. So we currently have a 4 and a 6 as our denominator. And can we just pick any new thing, like maybe 5? Could we say, let's change them both to have 5 as the denominator? The answer is no. We have to pick a multiple of 4 and 6. A multiple, some number that we can multiply 4 and get this number as an answer. So for example, for 4, some multiples of 4 would be 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and so on. Those are multiples of 4. And let's just pause here and look at why we have to pick a multiple of 4 and 6. Why we can't just pick any number, but we have to pick a multiple of our denominators. So the fraction we were just talking about was 1/4. We could look at either one, but let's look at 1/4. Here we have a picture showing fourths. And to show 1/4, we shade one of these 4 equal size pieces. Well, maybe I want to change this and I want to say I want 2. I want 2 as my numerator. So to have a numerator of 2, I'm going to need to split this fourth up here into 2 pieces. Now I have 2 shaded pieces. So can I say this is 2, 1, 2 out of 1, 2, 3, 4, 5 pieces? It's not 2/5 because these are not equal size pieces. So if I split this fourth right here in half, I need to split all of them in half. And what I'm doing is doubling the amount of pieces. So now this is 2 pieces, this is 2, and this is 2 because we need equal size pieces. So now this is 1, 2 pieces out of 1, 2, 3, 4, 5, 6, 7, 8 equal size pieces. So 2/8. And you can see 8 is a multiple of 4 because we multiplied by 2. And that's what we did. We multiplied each of our pieces by 2. And we also multiplied our numerator by 2 because that was also doubled. The amount of shaded pieces doubled when the entire amount of pieces doubled. And we don't have to do this just with 2. We could do any multiple of 4. For example, we can do one more here. If we, again, let's shade 1/4. One of the 4 pieces. And maybe this time we want to split it into 3 equal size pieces. So to have a new numerator of 3, and these should be equal sized, here's a numerator of 3. But we can't do our denominator yet because we don't have equal size pieces. So to get equal size pieces, we'll need to split each of these fourths into 3. So we are tripling the amount of pieces. So now we have 3 shaded pieces out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 12. And I could have figured that out without even counting because I knew that we tripled. This time we multiplied our original denominator times 3. We tripled. And we also multiplied our numerator times 3. So these are the multiples, 8, 12, and so on. And so those are the denominators we can pick. Something that we can multiply our denominator by, so we can multiply the entire amount of pieces. And again, so this is super clear, 1/4 and 2/8 and 3/12, they all represent the same amount. Whether we had 1/4 the original, here's 2/8, 3/12, they're all equivalent. They all represent the same amount. They're just different ways of writing the same number. Back to our original question, what denominators can we use for fourths and for sixths? Well, we know we need to use multiples, so let's look at the multiples. For 4, we've already gone through some of these. The first multiple of 4 is 4 times 1, which is 4. Second multiple of 4 is 8. 4 times 2 is 8, so we could split our fourths in half and get eighths. Or we could say 4 times 3 is 12. Which we showed again where we split our fourths, each fourth into 3 equal pieces. Or we could do 4 times 4, which is 16. 4 times 5 is 20. 4 times 6 is 24, and so on. The reason I'm stopping at 24 is I've looked at my answer choices, and I can see the largest possible answer is 24, so I don't need to write any larger multiples. There are many, many, many more multiples of 4, but we don't need to list them all because the largest number we're going to have to consider is 24. Let's do the same for sixths. We could leave our sixths alone, 6 times 1, and keep 6 pieces. Or we could double our 6. 6 times 2 would be 12. If we doubled the pieces, we would have 12 pieces. We could say 6 times 3, which is 18. Or 6 times 4, we could divide each of our 6s into 4 pieces. And we'd have 6 times 4, which is 24, or 24ths. And so on. Again, I'll stop at 24 since it's the largest number we need to consider. So down to our answer choices. What numbers could we use for the denominator? Could we use 8? Let's look at these lists. 8 is a multiple of 4, so we could definitely split fourths into 8s, but 8 is not a multiple of 6, so we cannot split 6 into 8s. So 8 will not work as a denominator for both fractions. How about 12? 12 we can see as a multiple of 4, and we showed that. We drew that already. And 12 is a multiple of 6. We could split our 6 into 2 equal pieces each, and we would have 12ths. So 12 does work. 12 is a denominator, a common denominator for fourths and sixths. 18 is here on the 6th. We could split 6 into 18 because 18 is a multiple of 6, but it is not a multiple of 4. So we can rule out 18. 18 is not a common denominator. And 24, you may remember, was the last number we wrote on both of them. So yes, 24 could be a denominator for fourths and sixths. So we could use either 12 or 24, and there's a lot more numbers we could use too as common denominators, but from these choices, we could use 12 or 24 as a common denominator for fourths and sixths. And just a note, lots of times people like to use the smallest one, the least common denominator, which in this case is 12. And it makes a lot of sense because it's easier to do computation with smaller numbers, but you don't absolutely have to use the smallest one. You could use 12ths or 24ths or lots of other options. But again, 12ths is probably the simplest one to work with just because generally it's easier to work with smaller numbers. But for this question, the common denominators we can use from these choices for fourths and sixths are 12 and 24.